Hi, I'm Alan Parry. I'm the CTO at YellowDog. In this short 10-minute video, I'm going to run you through an example of how you can use the power of the YellowDog platform to accelerate your workloads and take them from on-premise into public cloud. What we're going to use is an example workload. It's a Monte Carlo simulation that simulates the performance of a range of stock portfolios over time. But you could imagine really how you could use any type of application such as risk reduction, portfolio analytics, or backtesting applications. YellowDog Platform is the world's first cloud-native scheduler. We can take your existing applications, be they containerized, be they application binaries on Windows or Linux, scripts, legacy applications, and we can scale and give them huge power to either provide more accuracy or complete much more quickly in the public cloud. So let's jump in the demo. So what you're seeing here is the dashboard to the YellowDog platform. Let's give you just a very quick overview. It shows you some of the compute that we've got running, some of the work that's currently running through our various applications, and that we have a number of workers in the system to perform that work. What I'm going to do is, first of all, I'm going to show you that we have an on-premise system here running. This is in our data center. First thing I'm going to do is to configure this for use with YellowDog. So it's very simple to do. We just give it a token, which we go and get from our existing worker pool. And then we run the installer script. So that's registered this system with the platform. It's now available to receive tasks from any workload that we submit to it. And we can verify that by going and taking a look at the worker pool. And you'll see that there was none, there's now one sleeping worker. It's available for work. So what I'm going to do now is jump over to our demo application. So this is really to simulate and show you how you would integrate with the platform. It's very simple to kind of use our Java or Python SDKs to submit your work, to manage the compute, and to move data around. So I'm going to load a demo configuration. For our Monte Carlo workload. And now I'm going to submit some work to the system. And you'll see from the output here that what we've done is we've submitted 100 tasks. So let me explain what this demo is doing. So we have a workload which we submit to the platform that contains one grouping of 100 different tasks. Each of those tasks represents a Monte Carlo simulation for a randomly simulated stock portfolio. So we've got 100 different portfolios. For each one of those, each one of these tasks is going to collect up to 2 years of historical data showing how that stock's performed, and it's going to simulate how it will perform using Monte Carlo over the next 2 years of elapsed days. So if we go and take a look back at the platform now, you will see that we've just submitted this new workload here. There's 100 tasks in there. So you can see these are ready. And as these are picked up by the worker that we just connected from our data center, you'll see that these will start to complete, and we'll see some output into the object store. If I show you down the bottom of this interface, you'll see what we have is we have the single task group within this workload, and we have 100 tasks all in a ready state. So you'll see those start to transition to executing shortly. So what I should explain is that whilst this is a grouping of just 100 discrete, embarrassingly parallelizable tasks, it is very possible with the platform to connect these through using our resource framework to effectively create pipelines of tasks where inputs and outputs are chained together to produce complex analysis. So you can see that first task is completed already. If we take a look in there, you'll see that we've got a link within that task into the object store output that is produced. And if we dig into that, you'll see that we've got a range of tasks that are now starting to complete as they're executed. But you can see for each one, we are generating a chart, which is showing a range of the probabilistic performance of that portfolio over time. So if we go back to the work now, you'll see that this workload is now progressing nicely. 8 of the 92 tasks are completed. I'd like to accelerate this. I'd like to see the results from this simulation much more quickly. And to do that, what I'm going to do is jump back into our demo application, and I'm going to ask it to create a new cloud worker pool. You'll see from the output there, that's now completed. So what that's done is that's requested 5 cloud instances in the public cloud, and we've asked for that to be split across a range of cloud providers to give us some resiliency. If we go back to the platform and take a look now, you'll see within the compute section that we have that request provisioning. We've asked for a target of 5 instances, and if we scroll down, you'll see those are being provisioned across AWS, GCP, Azure, and Oracle Cloud Infrastructure. So as these machines provision and boot, what will happen is that the YellowDog agent installed on them will start to run. It will connect back to the platform, and it will say that it's available to collect tasks. We can see that in action if we go back to the worker section. You'll see that we now have a new worker pool here, again with the 5 expected. They're not yet showing as available. They're still connecting, and shortly we'll see them be available for tasks. And there you see that now 3 of them are connected. One of them has already picked up a task, and the 2 are about to. Now, what's going to happen is that actually there are some scaling properties on this worker pool. So we've said that we'd like to initially provision 5, but we're prepared for it to scale up to 10 if there is the workload available. And if we look back at the work, you'll see that actually there's 82 tasks remaining, so that there is capacity for that worker pool to scale up. So it's going to demand more workers, and in turn, this worker pool is going to scale up even further, and it's going to accelerate faster. There's really no upper limit within YellowDog in terms of how far you can scale these pools. We can go to huge scale. So you can see that we've got 5 currently alive, and we're expecting 10 because the worker pool's detected that there's more available work, and it's requested that from our cloud accounts. So provided that we have the quotas and the limits and the capacities available in the cloud, and by adding multiple cloud providers, we can increase our probability that we're going to find those. Those will provision, and those will start again receiving tasks from the workload. You see there now that it's updated. We've got 7 workers now working. 2 are currently sleeping as they're waiting for tasks. And it's interesting that one of them has actually been lost. I'm going to dig in and see why that might be. So what I can see is that actually these compute sources are using spot instances. So what's likely is that some of these have actually been preempted, but what YellowDog will do is actively re-provision those, and we'll continue at the capacity that we've requested. So I'm going to go back and take a look at the work and see how that's progressing. And you can see that we are now nearly 2/3 of the way through the work. So I'm going to wait for this to complete, and I'm going to show you what the output looks like, and then I'm going to explain how some of the configuration behind this works. And that's now finished. If we take a look down at the task group below, you'll see that all 100 of these tasks are now in a completed state. So as I said, each one of these is a discrete simulation of a stock portfolio. We can take a look into those. And as I showed you earlier, each of these simulations has its own output chart where you can see the distribution of the performance. So let me show you a little bit about some of the configuration, especially of the cloud compute that we provisioned in the middle of that simulation. If we go back and take a look at the worker pool that we created in the cloud, so you can see that these workers are now sleeping. If we actually take a look at the properties on this worker pool, you'll see that the idle node shutdown is set to 5 minutes. So after 5 minutes, these nodes will automatically scale back down to 0 and deprovision, and that'll return our cost profile to 0 for this workload. If we take a look at the compute running behind here, you'll see that there's a template associated with it. That's a static template, which means that effectively we've determined exactly the sources of compute that we want to use. There's a T3A smalls in AWS, E2 smalls in GCP, standard A1s in Azure, and the E2.1 VMs in Oracle Cloud. This is a split template, so the system's going to try and automatically balance the work across those systems. So the instances that we provision will be equally in number across the different providers. We can actually do things like waterfall provisioning, where we try and prioritize one region or one provider versus another. we can also use what's called a dynamic template within YellowDog, where actually we're very loose with the requirements. So we say things like the compute must be provisioned in the UK, for example. We're looking for the cheapest price performance core available across any cloud provider. The platform will automatically select and provision that for you, and that will then be available for the application workloads that we submit to the platform. Okay, so just for some good housekeeping, I'm going to go in and shut down that worker pool myself automatically. But actually, if we just left it after 5 minutes, it would have cleaned itself up as well. Okay, so that's the end of the simulation. You can see that it took about 9 minutes for those 100 tasks to execute across up to 11 different workers at its peak in the cloud and in our on-premise data center. Thanks for watching this video. If you'd like to learn some more, we've got a range of videos on our website at yellowdog.co.